Assalamualaikum warahmatullahi wabarakatuh and greetings. Let's begin. Hi everyone, my name is Muhammad Zarif Lokman bin Jamadulai. My student ID is 2021-200998. And today I would like to dive into my chosen topic to help you understand better and also help me increase my own understanding of this topic that I am about to present today. All right, as you can see on the screen, our topic for today is empirical and molecular formula. Sounds kind of familiar, right? So for most of you, you have learned about this topic during your high school years over and over again. And therefore, hearing me explain this same thing over again makes you feel bored. Am I right? But keep in mind that ever since high school, the questions regarding this topic are seldom looked over by students, thus causing them to make careless mistakes and thus causing them to lose free marks in the exams. Why do I say free marks? Because this topic is so easy. Yes, it has been proven that there are still a minority of students who manage to lose marks in questions regarding this easy topic. So I am here to help you and also to help me grab those free marks. Ready? Let's go. All right. We'll start first with empirical formula. What do you understand about empirical formula? All right. The definition of empirical formula is a formula that states the simplest whole number ratio of atoms in a single compound. All right. You should highlight these words. Simplest whole number ratio of atoms in a single compound. Highlight those words. You should understand those words, and if you can grab the definition, the true definition of those words, you should have no problem with the concept of empirical formula. Right, I'll be straightforward with you. When you get a question regarding empirical formula, they basically just want you to make the subscripts in the given formula smaller. That's it. It's that simple. So what do I mean by subscripts? If you don't know, in a given formula, for instance, glucose, C6H12O6, right? So subscripts are the small numbers right next to the elements. Okay, for instance, C, and then you have a small 6 next to it, H, and then you have a small 12, and then O, and a small 6 next to it. Those small numbers represent the number of atoms of that particular element in a single compound. Those small numbers are called subscripts. All right. So they basically just want you to make the subscripts in the given formula in the question smaller. But how do you make it smaller? Now, this is the part where students seldom make wrong calculations. Okay, it is not as simple as maths where you divide numbers in a given formula with one number that can divide with every other number, where you can get a smaller whole number ratio. Here, the process is totally different. This is chemistry, right? Let me take you through it. How to determine an empirical formula. Right, this is the process. Okay, this is what you have to do. There are 4 steps. These are what you have to do in order to grab those free marks easily. I promise you, if you follow these 4 steps, one by one, you study each of these steps and you master each of these steps, you would have no problem getting those free marks, right? Let's get into it. Okay, step 1. of how to determine an empirical formula. Step 1. Start with the number of grams of each element. Okay, so in the question, usually they would provide you with the number, with the mass of the elements in that particular compound, right? But as you see, where I've put here, mass and mass in brackets grams or percentage, right? If the question gives you mass in grams, you would have no problem. That is your mass, right? But what if the question provides you with percentage? What do I mean by percentage? For instance, they give you 40% of carbon or 16.3% of nitrogen. What are you going to do? Where is the mass? Those are percentage. It is clear that percentage and mass are two different things, right? But here, in determining an empirical formula, mass, the percentage is the mass, all right? The percentage of the element, for instance, 40, like I said just now, 40% of carbon, that 40, the number 40 is your mass, right? Ignore the percentage, just take the number 40 and 40 grams. I'm sorry, 40%, the number 40, that is your mass. Use that in your formula. The formula is in step 2, all right? Let's get into step 2. Step 2, convert the mass of each element to moles, right? So in this process, in this step, we will use the famous formula that we seldom use during our high school years, right? The formula is N, which is mole, is equal to mass of element. I put it here in bracket, grams or percentage, right? So that you won't be confused. Grams or percentage divided by the molar mass of elements. Where can you get the molar mass? You probably should know by now that you can get the molar mass of element in the periodic table of elements, right? So step 1 done, step 2 done. Okay, convert the mass of each element to moles. Using the formula, mole is equals to mass over mass of element, grams or percentage, over molar mass of elements, right? Step 3, divide each mole value by the smallest number of moles calculated. Now here, if you read the step 3 slowly, you would have to read it a few times for you to get it, right? So basically what it means is number of moles divided by the smallest number of mole of an atom which is in the particular compound. Right, in the compound you have different atoms, right? For instance, I gave you an example just now, glucose, C6H12O6, right? So there are different atoms in a compound. So when you are calculating using the formula, mole is equal to mass over molar mass, right? Use that formula to find the number of mole of each atom. Okay, for instance, in glucose, number of atoms of carbon, number of atoms of hydrogen, number of atoms of oxygen, and then you must observe which atoms has the smallest number of moles. You take that smallest number of moles between the three. In this example is glucose, CHO. You take the atom with the smallest number of moles and you divide it with other atoms number of moles, and then you will get the ratio. All right, that ratio you would use to build your empirical formula. Now step 4, round to the nearest whole number. If the number is too far to round, x.1 until x.9, then multiply each solution by the number to get the lowest whole number multiple. Okay, moving on. Now this is what I was talking about before this. This is step number 1. Step number 1 is your own initiative, look for the mass. For instance, in this question, they provide you with percentage. See here, percentage. So you use that percentage over molar mass to get the number of moles, and then find the ratio with using the number of moles of each element and divide it with the smallest number of moles between those elements. And therefore, you can use it to find your empirical formula. All right, moving on. Next is molecular formula. Molecular formula is a formula that displays how many atoms or ions of each element combine to create that particular compound. Now here, molecular formula is the actual formula, right? The subscripts in that formula is the real number of atoms that are required to build that compound, right? It's not the simplest whole number ratio. It is the real number that is needed to create that particular compound, right? Here's a tip for molecular formula. To find molecular formula, a molecular formula for a compound can be determined if the empirical formula of the compound and molar mass of the compound is known. We'll know further after this, right? So steps in determining molecular formula. Step 1. Calculate All right. Step 1. Calculate the mass of the empirical formula. Okay, you can use the formula mass over molar mass to find the mass of the empirical formula of the compound. And then step 2, divide the molar mass of the compound by the mass of the empirical formula to find the ratio. Calculate the total molar mass of each element in the compound, okay? And then you divide it by the mass of the empirical formula that you have calculated in step 1. Now step 3, multiply all the atoms, subscripts, right? Subscripts, which I have explained earlier in the video, by this ratio, by the ratio that you have got in step 2. Divide all the subscripts by this ratio to find the molecular formula. The ratio obtained multiply with the subscript of each element. Okay, multiply it with each element. Okay, here is an example question. For a compound whose empirical formula is CH2O, the molecular mass was found to be 180. Usually in the questions, they will provide you with molecular mass, right? So what is its molecular formula? So step 1, calculate the mass of the empirical formula. Okay, not molecular, empirical formula. Calculate the mass. So you use the formula mass over molar mass, and then you will get the mass of the empirical formula, right? So step 2, divide the molar mass of the compound by the mass of the empirical formula to find the ratio. So ratio is equal to molar mass given, okay, in this question is 180, divided by mass of empirical formula of compound. So here we'll get 6. So step 3, multiply all the atoms, subscripts with the ratio to find the molecular formula. So the original formula, the empirical formula is CH2O. So you multiply each subscript in the formula, empirical formula, with the ratio. The ratio in this question is 6. So this is C1 times 6, you will get C6. H2 times 6, you will get 12. And O1, you times with 6, you will get 6. So your molecular formula is C6H12O6 glucose, which I have been using from the start. So I think that is all from me. Hope you understand my explanation, and um, thank you. That is all.